Hi everyone, I'm Rob Sumsky from CoreOS and now Red Hat, and I'm thrilled to announce that the Operator Framework is joining the CNCF as an incubating project. CoreOS introduced the Operator concept in 2016, followed shortly thereafter by the Operator Framework, which is a set of tools to help you build, ship, and discover operators. Operators are operational procedures and best practices that are codified into software. They make automated day 2 operations possible in Kubernetes and model the complexities of today's distributed systems. For example, there isn't a concept of data rebalancing inside of Kubernetes, but that can easily be built on top of the Kubernetes APIs with the Operator Framework. These types of concepts are required for running what we call the third wave of applications on Kubernetes that are these really complex distributed systems. The Operator Framework comes with all the tools required to build this software as a software developer, and as a cluster administrator, everything you need to safely install, upgrade, and manage your operators. These tools tie into other CNCF projects like KubeBuilder, Helm, Cuddle, and popular open source like Ansible. The framework is loosely coupled, so if you have a testing tool that you like, for example, you can keep using that. And if you want to build your operator outside of the SDK, that's totally fine. You can still run it with the Lifecycle Manager. The framework has 3 different flavors of SDK today, with more to come in the future. They're suitable for all roles to create operators, from developers that might be familiar with Helm, to infrastructure-focused engineers that maybe use Ansible playbooks in their job today, and then full-on distributed systems engineers that maybe are very adept at client Go and other Kubernetes tools. All flavors of the SDK integrate with the packaging and testing tools that are required to get your operator out to its end users. Testing an operator is extremely critical, and this is why I suggest that everybody use one of our SDKs or at least join our community. It's critical that your operator functions correctly when it's manipulating these very complex applications. And our experts in the community have modeled all types of applications as operators. We can help you save time and avoid some bugs. Plus, it's just been really fun to see all the projects come through our community call and help people out. Now, once you've written your operator, you need to hand it off to your colleagues or your customers to actually run it. This is where the Lifecycle Manager comes into play. There are actually a lot of tricky problems here that you might not even know you have yet, like collision detection for CRDs. Picture you have a CRD that's managing a database, but then there's another operator that wants to also manage that database. No good. Same thing with like a machine learning application. The lifecycle of the CRD itself is also important. Those just going to their V1 status in Kubernetes. And so the Operator Framework can help you update your operator and manage your CRD as part of that process. There's too much coming up to cover it all, but I want to give you a sneak peek at where we're going in 2020. First, we're moving over to a new bundle format. This is how the operators are collected into catalogs and shared between clusters. We have a new tool, OPM, which will allow cluster admins to curate that set of operators, including for disconnected clusters. And last, a new operator API is going to land, which is a newer, simpler way to interact with operators on your cluster for both admins and developers. Next, let's take a deeper look at operators.
If updating and maintaining containerized applications requires manual processes and regular human intervention, then it makes managing applications at scale difficult. Worse, it leaves those systems vulnerable if they are not properly configured or up to date. Kubernetes operators change this. An operator extends Kubernetes to streamline and automate installation, updates, and management of container-based services. Kubernetes runs and manages containerized software according to your specifications. It does this through a control loop that continually checks your cluster to ensure your described ideal state, with the right number of instances, on the right infrastructure, in the right places, with the right deployment, rollback, and failover strategies. Kubernetes automates most of these tasks for stateless applications, but most software isn't stateless. An operator is a scalable, custom version of this control loop for stateful applications. It determines if your application is running correctly according to your instructions and in line with best practices from the experts in running that app. If it's not, the operator automatically acts to correct it. Operators also let users interact with a complex application as a single object on the cluster, thanks to custom resource definitions, or CRDs. Users interact with the operator through those objects, which expose only the options that make sense for the application. An operator can also set a new ideal state. When it does, it updates the service to that latest version, ensuring your system is more secure and up to date.
I hope you enjoyed that deeper look. I want to invite you to check out the framework at operatorframework.io and join our growing community. We'd love to have you.